well, some of the students ask for re-explain the derivative of trigonometric functions. Okay, well, let's take f of x equal sine x and f of x equal cosine x and f of x equal tan of x. Okay, now the derivative of sine is all the time cosine. So sine will become cosine. And derivative of cosine is sine. Look, so sine will become cosine. Cosine will become sine with one difference. Sine directly change the sine to cosine without changing any signs like positive, negative. But cosine, when you change it to sine, you have to change the sign that precedes the function. Okay? What about tan? Tan has two derivatives. Either you have cosine square x 1 over cosine square x or 1 plus tan square x. Okay, those three functions, look, the angles or the thing that is inside sine, cosine, tan is all just x. But what if I had something else inside the sine? F of x is equal sine 5x. Okay, now when we want to find the derivative, we will change the sign to cosine, keeping whatever you have inside the sign, which means the angle. So the sign going to be cosine 5x. But here I have to say times times the derivative of inside the the derivative of the angles. Okay, what do you have inside the sign? I have 5x. What is the derivative of 5x? It is 5. So that means the derivative of sine 5x is cosine 5x times 5. Why 5? Because 5 is the derivative of 5x. What if I had cosine 1 over 2x? Now, what I have to do? The f will be f prime. The cosine will be negative sine of what? Sine whatever you have inside the function, the main function, which is 1 over 2x. But I don't have to forget that we have to multiply with the derivative of the angle. Okay, you have 1 over 2x. What is the derivative of 1 over 2x? It's 1 over 2. So this is the derivative of this function. Okay, now I have tan, for example, 2x. I ask for the derivative of the function. So if it is written part, it's up to the student which one you gonna use. So if a student like to use the cosine, you can do this. You will say 1 over cosine square of whatever you have inside the tan, which is 2x. Okay, now since x was alone, so derivative of x is 1. That is why the numerator was 1. Sorry, the power is off. Okay, now what is the derivative of tan? What is the derivative of inside the tan, which is 2x? Okay, derivative of 2x is 2. That's why the numerator is going to be 2. Okay, now what if a student didn't like to use the cosine and he or she wanted to use the tan? What you're going to do? You will say 1 plus tan square of whatever you have inside the tan, which is 2x. But I have to say times the derivative of the angle. Okay, what is the angle? It is 2x. What is the derivative of 2x? It is 2. So you have to say times the derivative of the angle. Okay, now third type. F of x is equal 3 sine 2x. Look, here I have a coefficient and I have an angle. And I want to ask about the derivative of the function f. So f will become f prime equal all the time keep the coefficient without any change. So keep the 3. So here I kept the 3. Now I have to derive the sign. Sine will become cosine, keeping the same thing in the question, which is 2x. Look, cosine 2x. So I changed the sine to cosine. But we said when we derive the sine, after changing sine to cosine, I have to say times the derivative of the angle. What is the angle? Here is the angle, the 2x. 2x is the angle, okay? Derivative of 2x is 2, so that means I have to multiply it with 2 times 2. So the final answer is 6 cosine 2x. Okay, f of x is, for example, negative 1 over 2 cosine 4x. I want to derive it. F will become f prime, change the coefficient, cosine gonna be negative sine, okay, negative sine of whatever you have inside the cosine, and times the derivative of the angle. What is the derivative of the angle? It's 4x. What is the derivative of 4x? It's 4. So times 4. Now here see that we have simplification. Divide by 2, divide by 2. Here is 2. Negative, negative, it's positive. So the negative disappeared. Now the derivative of minus 1 over 2 cosine 4x is 2 cosine 4x. 2 sine 4x. Let's see, 5 tan 2x. Okay, f will become f prime, keep the 5. For example, I'm gonna use this one. Okay, so tan, it will be 1 over tan square 2x times the derivative of the angle. Which angle? This is the angle 2x. What is the derivative of 2x? It is 2, so here's 2. Now look, you have 2 over something times 5, so that means I can multiply these 2. So the final answer is going to be 10 over tan square, sorry, cosine square, I'm sorry, my bad, cosine square of 2x, okay? What if a student wanted to use the second way, this one? Okay, so we have to say keep 5, derive tan 2x to be 1 plus tan square 2x, okay? So here I derive tan. After deriving tan, I have to say times the derivative of the angle, which is 2. So 2x, the derivative of 2x is 2. So times 2. Here's the answer going to be 10, 1 plus tan square x. And here is the derivative of the trigonometric function. But of course, we have many other examples like sine and cosine raised to powers, multiplied with another function, divided by another function. But as we said in class, those are the only parts exist in your curriculum. So for the next rules, we're gonna study it in next year. Good luck.